Today we are going to be talking about histograms and stem plots. Don't know why this cartoon is on it, but it's kind of funny. This is the president of the math club that says that since 21% of the boys and 30% of the girls support him, he'll get 51% of the vote, which we know can't happen. Okay, histograms and stem plots. These are going to be great ways to show where your location is kind of centered around, or where your data is centered around. That's your location, where your data is kind of centered, the location of your data. Histograms and stem plots show frequencies. Of data in certain ranges. And the best way to kind of talk about them and learn histograms and stem plots is just to make a couple. We'll make a stem plot using the data. We'll make a histogram using the same data. Okay, so let me skip ahead to some stuff. How to make a stem plot. Okay. We got Joey. Joey's got 14 quiz grades. Go ahead and write down these quiz grades because we are going to be using them to make a stem plot and to make, I'm also going to include a extra data point and a histogram, okay? We'll make the stem plot over here. We'll make the histogram over there. You'll see how similar they are, how they show really the same thing. Okay. Typically with a stem plot, we will put the tens place to the left of a line. And to the right of the line, we will write down the ones place, which will be able to show us the amount of frequencies of quiz grades per kind of tens, per range of tens. So I first start and I notice that my low grade is a 55 and my high grade is a 98. So that means my values are going to go from the 50s all the way up to the 90s. These are my tens place. I do not have a data point in the 60s. However, I include the tens of everything from our max to min. I'll say from min to max. Okay. And then all we do is we just start placing in our data in order into our leaves. So here's our stem. We will make a leaf for 55. You combine 5 and 5, you read this as 55. I get rid of 55, I don't have to worry about it. I look for any 60s and there are no 60s, so I leave it blank because there's no data. Now I look at my 70s. Well, I see I have a 76, a 75, a 78, and a 74. I will list off those numbers by separating the ones with columns, commas, not columns, with commas. So my first value is 74, comma, I place a 5 next to that. That stands for the data point 75. I place a 6 next to that. That stands for the data point 76. I place an 8 next to that. That stands for the data point 78. What this shows me is that there are 4 quizzes in the 70s that Joey had. Simple enough to understand. Not only does it show me the frequency, but it also shows me the amount. So 74, 75, 76, 78. Okay? You guys do the rest. I'll do the rest. We will compare our stem plots. Now, it's important to kind of separate your numbers, your commas, in order so that they're kind of all lined up. That way you can really compare how much data you have in each range. So you can see you had more 80s and more 90s than you have 70s, okay? I had 5 scores in the 80s, 5 scores in the 90s, 4 scores in the 70s. That is a stem plot. A histogram is really going to look the exact same as your stem plot. However, we are going to rotate the axes. On the y-axis, there will be amounts or count. On the x-axis, there's going to be your range of values. And in this situation, since we know the low score is a 55 and the high score is a 98, we're going to go up by 10s, and you don't have to go up by 10s, but in this situation I will. 50, 60, 70, 80, 90, and 100. Okay, and what you create are these bins. These ranges of values. Okay? We go from 50 up to 60, but not including 60. That will be this first bin. Okay? So the value that's on the left will be included in the one on the right, in this bin on the right, and then it's going to go up to 60, but it's not going to include 60. And then we'll go from 60 to 70, from the exact value 60 to like 69, I guess we could say, from 70 to 79, from 80 to 89, from 90 to 99, just kind of like that. So 50 to 59, 60 to 69, 70 to 79, etc. Okay? And what we do is we just count the amount of frequencies we have in each bin. Okay? So in this situation, just like in my stem plot, in the 50s, I had one grade, 55. In the 50s, I had one grade, 55. So for the amount, we'll put just a 1, and we'll see kind of based off of how many we have in each one, what our y-axis is going to be. But what I just create is a simple little bar showing that I had one score in the 50s. Okay? I had no scores in the 60s. I had 1, 2, 3, 4 scores in the 70s. So 1, 2, 3, 4. In the 70s, I will place a bar at 4. Okay, you guys fill in the rest. In the 80s, I had 5. In the 90s, I had 5. That's a histogram. That's a stem plot. That's a histogram. That's what we're going to be doing today, is kind of creating histograms and stem plots. But more than creating and showing things, we're going to be analyzing what we see. Okay? We're going to be analyzing how our data is spread out. And that's the great thing about stem plots and histogram. It shows how our data is spread out. Now, advantages to stem plots. Stem plots, you can see every single data value. Okay? Histograms, you just see amounts. So you don't know exactly what your data is if you're just looking at a histogram. However, you can see how it's spread out. Okay, so that's advantages to disadvantages. But we will be using histograms a lot in this class. Actually, a lot more than stem plots. Because once we have lots and lots of data, creating stem plots becomes more and more difficult to do. And we'll find that, you know, we have calculator programs that will create histograms, but they don't create stem plots. Okay, so that's why we'll use histograms. Okay, any questions? All right, well, let's talk about how we're going to analyze this data, like this histogram or this stem plot. We will talk about the following. CUS is how we will analyze and describe the data that we will be able to visualize and see using stem plots and histograms. CUS stands for center, unusual features, spread, and shape. The center, right now, we're just going to say it's the location in the middle of all the data. Okay? However, we will find exact center measurements, which are like a mean or an average or a median. But we're going to learn that next class in the following class. Right now, we're kind of just going to say about where is the center. We'll talk about unusual features like outliers. You've heard of outliers before. Okay? That is a data piece that is far away from the rest of your data. Okay? We will define exactly what it means to be an outlier. There's an actual definition of what is an outlier and what is not an outlier. Okay? We will talk about gaps and clusters. That is unusual features. Gaps is if we have a spread where there is no data. Clusters if we have lots and lots of data, all clustered around a specific location. The spread, today we're kind of going to focus on the range, like how far away the max is and the min. But in the future, when we talk about spread, we're going to use these measures of variability, which are like standard deviation and variance, or interquartile range. IQR stands for interquartile range. Those are different things we will learn in the future, okay? Right now, today, we're just going to talk about like the range of max versus a min, but we can use different ways to describe the spread of your data. And then the shape. How is our data distributed? Okay? Examples of the shape is symmetric, skewed, uniform, bimodal. We will go over today the different shapes that you will see our data located if you look at either a stem plot or a histogram. For right now, to introduce shape, we're going to look at just stem plots. I'm going to change up my ink color again. I mean, not Stemplots. For shape, we're going to look at histograms. Okay? So here is a histogram. This is South Pole temperatures for a certain year. Okay, it's 365 dots, I believe, up on that graph. So South Pole temperatures, average temperatures on a given year. This is kind of like a histogram. It is showing locations of our temperatures and then quantities, okay? Probably instead of dots, you would be using bars, but this is almost like a cross between a Stemplot and a histogram. You could kind of look at this data and say, you know, if I average all these together, my center is going to be around -50. We can see there's an unusual gap that never in one year the South Pole temperature was -45 degrees. We can see that the maximum and the maximum temperature on the South Pole is -21 degrees, which is very cold for a maximum. The minimum was -69 degrees, which is crazy. Okay. Shape, we call this shape a trimodal. That just means it has 3 humps. We will discuss that. It's not super important that we call this a trimodal. And that's kind of the idea. CUSS, center, unusual features, spread or range in this situation, and then shape. Okay? Let's talk about shapes. First shape that you need to be familiar with is a normal distribution or a symmetric shape. Just go ahead and sketch the curve. Don't worry about this stuff on the x-axis. We will talk about that more in the future. This is called a symmetric distribution or a normal distribution. And we are discussing shape right now. Okay? The center, mean, median, and mode, right here in the middle of the data. Makes sense. There's no unusual features. Your data is centered around the mean. The spread, don't worry about this, but in the future we're going to use standard deviation and variance to find the spread of this data. You can talk about the range if you are, if your data is symmetric or normally distributed, but this is what a normal distribution looks like, a symmetric. Next shape is something that is skewed right. When we have data that is skewed right, most of our data points are here on the left. We will have outliers on the right. Because most of our data is on the left and our outliers are on the right, what happens is our mean gets pulled to the right because the outlier pulls it that way. Since our mean is pulled to the right, since our outliers are the right, that's why we say this is skewed right. A lot of students have difficulty remembering that this is skewed right. They think because the hump is on the left, you say this is skewed right. But no, you think about the skewness in terms of where the mean is being pulled. Okay, and here, because of our outliers over here, the mean, which in the last situation was right in the middle, this would be the mean right here. Instead, with a couple extra outliers over here and over here and over here, all of a sudden the mean gets pulled to the right. Okay, we are skewed right. Okay, spread, we will talk about ways to talk about the spread. You can really talk about the range. We will use interquartile range. It doesn't matter. Well, if we talked about skewed right, let's talk about skewed left. Here, our outliers are to the left. Our data is centered toward the right. The mean is getting pulled left towards our outliers. Instead of our mean being right in the middle of our hump, instead the outliers pull my mean to the left, and we end up with the mean being less than the median. Okay? That is a skewed left distribution. And then we have a uniform distribution where everything is kind of flat. This is an example of something that definitely should have a uniform distribution. It's not exactly uniform. However, if we increased our sample size, it would get more and more uniform. What we did in this situation is counted when we rolled a six-sided die, what number showed up every time. Okay? And since it is a fair six-sided die, you would think the probability of each number showing up is equal. So if you just keep rolling it, eventually you will see that all of these numbers would be the same. So across some line. There's no outliers. The mean and the median will be in the same location. Data's spread out evenly across the entire range. That's a uniform distribution. This is a bimodal. You saw a trimodal, bimodal, polymodal is just multiple kind of humps. No necessarily, no outliers. The mean and the median will be in the middle right here. However, like the mode and most of the data will be centered in two locations. Okay, so this would be like a bimodal. You won't see this much. You won't see this that often. What you will see more often than not is this. I'm going to talk about how this is very, very powerful, this distribution. Okay. Well, let's go to quiz grades and the quiz grades that we just calculated. I think that's next. Here's a stem and leaf of age of death of U.S. First Ladies. Okay, let's talk about this first, actually, before we get to the quiz grades. Okay. Now, I could take this data and spin it on its axis and create a histogram, right? What would the data distribution look like? Would it be normal? Would it be skewed right? Would it be skewed left? Would it be uniform? Let's see. It looks like the age of death of U.S. First Ladies, we have mostly 60s, 70s, and 80s. So if I kind of did a histogram, I'd have, 60s being here, 70s being a little bit less, 80s being here, and then I'd have 50s, which is less than that, and then 40s, which is less than that, and then 30s, which is like that, okay? And what I could do is kind of create almost like a curve that goes over that data, right? You guys write down on your paper if that is symmetrical, normal, skewed right, skewed left, uniform, or bimodal. And then talk to your neighbor about what you think it is. Ready, set, go. Okay, good. It's skewed left, right? We have most of our data towards the right. However, we do have some outliers, not necessarily outliers, but a few pieces of data on the left, on the low end. This would be skewed left. So you could kind of see it if you drew something like this, but you just have to flip it onto its side. And you can see that the mean and the median are not going to be at the same location. We're probably going to be having a lower mean than our median, which is true. Okay? Skewed left. Center, right around 65. We'll talk about calculating the exact center. The spread, in this situation, the range is between 34 and 97. Okay? That's the idea of the spread, the range max minus min. We talked about how to make a stem and leaf plot. Let's look at these quiz grades. Now, this is probably going to be consistent for all grades. Grades are all going to be skewed in what direction? Left. Why? Because there's a max grade of 100 that you can get. So all of a sudden, just people are going to be kind of pulled up to that max grade. There's going to be most of our grades going to be in the 70s, 80s, and 90s. However, there will be some students who do not show up prepared who will get a 50 or a 40 or a 30. There won't be that many of them, but that will skew our mean, our total average, down. So most likely, if we wanted to look at the actual, center that you should compare your grade to, you should probably look at the median and compare your grade to the median and see how you do compared to your peers. Okay? All right, next. So we talked about kind of spread. There's another kind of stem plot we need to learn is a split stem plot. When there are very few stems or less data out there, we can split and make two stems. So instead of going, 50s to 80s, 50s, 60s, 70s, 80s, 90s, 100s kind of thing, instead of doing that, we will split and we will say, okay, let's go 50 to 54, 55 through 59, 60 through 64, 65 through 69, 70 to 74, 75 through 79, 884, 889, 994, 999. And you guys could create your split stem plot using those quiz grades from before. Okay? We know we had a 55. Well, that would go in the second 5. We know we didn't have any 60s, so we would skip both 60s. What was the next data piece that we had? 74, so 70 through 74. Then 75, 76, 78, 80, 82, 84, 86, 87, 90, 91, 93, 96, 98, just like that. Okay, this would be a split stem plot. It just shows more little bins that you can put your data in. And we could do this with a histogram as well. Instead of doing the 60s, the 70s, the 80s, the 90s, I could have gone from 50 to 55, from 55 to 60, from 60 to 65. You can do whatever you want for both of these, really, if you think about it. Okay? There's a back-to-back stem plot you need to be aware of. It's just putting two stem plots next to each other to help you compare two sets of data. We will be doing this for your next quiz. I believe you have a back-to-back stem plot on your homework. Now, write down back-to-back stem plot and just write down how on the left side, the stem plot is backwards in terms of its leaves. Notice we go a 2, then a 5, a 4, then a 5, a 1, 1, 6, 6, 6, 7, 9. It is backwards. Compared to our normal stem plot with the stem on the left and the leaves on the right. Okay? But here's a good comparison that we can do. We can look at who is the better home run hitter, Babe Ruth or Roger Maris. Roger Maris is known for setting the single season home run record before steroids became big in baseball of a value of 61. Well, if you looked at Roger Maris versus Babe Ruth, who would you consider the better home run hitter? Probably Babe Ruth. And why is that? Yeah, because he's got more higher years. He has 1, 2, 3, 4, 5, 6, 7 years where he hit home runs in the 40s, right? How many did Roger Maris have in the 40s, Mr. Herzberg? None. Yeah, man. So Roger Maris looks like he just had an outlier, a lucky season where he hit 61. Who knows what he was on, but Possibly a lot of luck. Possibly he was into steroids back in the day. I don't know. But that appears fishy, if I look at that. I see the 60 and I say, yeah, that's expected out of Babe Ruth. But I see the 61, it's like, I'm not sure if that makes too much sense. Okay. Typically outliers in sports, there's something fishy going on. Okay, so who's better? Probably Babe Ruth. Maris has a possible outlier. Maris has a larger spread compared to Babe Ruth's. If you looked at the shape, looks like Roger Maris is going to be skewed to the right. Skewed right. Whereas Babe Ruth looks to be a little bit normal or symmetrical. Okay, cool. Okay, we talked about histograms. Now here's a histogram of people's age in cities between Houston and Dallas. Okay, people's age in between Houston and Dallas. Amounts. What is the shape of this? Is it normal, skewed left, skewed right, uniform? Mr. Johnson. Skewed right. Okay, we can kind of see that it's skewed right. Good. We talked about how to make a histogram. We use our data to make a histogram. Now, we will find out that we can use our calculator to make histograms, okay? And it's going to be very helpful for us to use our calculator when we have a lot of data. So, here is a lot of data. These were your Unit 2 test results. We will create a histogram to see the distribution of all of my stat student scores on the last test. You'll see your test grade in there somewhere. Here's how we're going to do it. Everybody has a calculator out. Everybody ready to go. In this class, you will familiarize yourself with the stat button. Everybody go into your calculator and click the stat button. Okay. We will use all three of these columns in this class. So be ready to go to all three of them. But before we go to all three of them, we need a place to enter in all of our data. If you go right from stat and click enter to get into edit, here is where we enter in data. Okay? Now, I want you to enter in all of these test grades. However, this is in two columns. If they're all the same data, enter them into one column. So just enter it into L1. All you have to do is type in the number and press enter. And the number is saved. Okay? Do that for all of them. we should have 38 total numbers. The 39th number should be blank. Can I get a confirmation that that is what other people got? Good. Okay, everybody take a second, make sure you have 38 numbers entered in there. Okay, if you need to write down these steps, you know, stat, edit, maybe that's your first thing that you write down. Enter data, stat, edit. Sorry, go back. Should be 38 numbers. The 39th should be blank. Okay. Okay, so making a histogram. Step 1, enter your data. You're going to go into stat edit. Step 2, you're going to turn your stat plot on. And you will select the histogram graph. Let's go back. Okay, so we are used to plugging in functions into y equals x squared plus 3x plus 7. Here's y equals. You know, you can plot that, plug in graphs. Your calculator will plug in x's, you get your y's. Well, if you go into Statplot, this is where your calculator will take your data from the stat part of your calculator and graph it in different ways. So instead of y equals, we now use Statplot. And we can turn our Statplot on. Once we turn it on, we should see this should be highlighted. It might not be highlighted right now, but when we go back to it, it will be highlighted. Okay. Then we will go to type. Let me fix this to type. And you're going to select your histogram graph, which is a bunch of little bars. Go to Statplot. Statplot is up here above y equals. Since it's in blue, you need to press second first to get to Statplot. Make sure your plots are on. Press enter. You go into plot 1. You go down into type. You press enter on the histogram type. You can see that we have, a scatter plot. We'll have a line graph. We will have these box and whisker plots as well that we will be able to use. We're telling our calculator to use list L1. That's the list that we plugged in our data into. The frequency is how many, I've tried to play around with frequency. I haven't been able to work with. It's like how many lists we're pulling our data from, but I haven't been able to work for it. Okay. Now, if you go into graph and your zoom is standard, you're not going to see anything, because this is from -10 to 10 and from -10 to 10 on the y-axis. Instead, what your calculator does a very good job of is zoom stat. So if you go into zoom and you click zoom stat, which is, I believe, the 9th zoom. And you press enter, all of a sudden you get a histogram. Let's see the histogram on everybody's calculator, please. You can press trace to see your data. Press enter. Turn it on. Do you have your data entered?
No, the entry have the wrong numbers, so it's redoing it. Change your code.
Okay. Go back to stats. And when I press trace, what we see is our calculator being very, very friendly to us, and they're showing us an N. That is an amount of data, amount of our sample. 4. We had 4 scores on our test between a 62 and a 68 from all of my students. Okay? It says min and says our max is less than 68. If I go to the right, I can see all of the values of all of these bins. Which is cool. Now, where's the center, approximately? I don't know, probably like an 85. Is there any unusual features? I say no. There's no gaps, there's no crazy things. The spread, we have a max of 100, a minimum of a 60, whatever, 62. So our spread is 38. What's our shape here? Skewed left. Okay? Our mean is getting pulled to the left. Now, what I don't love, though, about what my calculator did, though they did a very good job, is I don't love how our bins are from like 74 to 81. And here it's from 81 to 87. And here from 87 to 93.6. That's not great. What I like as a teacher is I like to see how many A's, how many B's, how many F's. Okay? So we're going to change that in a second. Do we have any questions and anybody not be able to pull this up? Statplot.
I know how to do that. I just wanted to listen to you explain it.
Okay, I just want to see it on your calculator. Anybody need any help? Let me see all of our beautiful histograms on our calculators. If we entered in the data wrong, it's probably fine. You're going to have something a little bit off than mine as long as we could see it. Put your phone away. You guys are killing me today. Okay. Enter your data. Okay? Set, I want 80s, I want 60s, I want 70s, I want 80s, I want 90s, I want 100s. What you will go to is your window. Your window and adjusting your X min, X max, and your X scale will adjust your bin lengths and where your bins start from and end. Okay? So let's write that down as well. Window is used to adjust bin sizes and lengths. You will adjust your X min, your X max, and your X scale. The length will be the X scale, the sizes will be X scale, but kind of starting and ending points will be X min and X max. Okay, so I want 60s, 70s, 80s, 90s, 100s. So I will start at 60. I will go to 100, and I want to go up by 10s. My bins were just adjusted. If I press trace, however, I see we had 4 Ds, 4 Cs, 11 Bs, and 17 A's. And we had 2 hundredths. Now what we can see is that I don't see all that hundredths. I don't see the 17 A's. What we will have to do is adjust our Y's to see all of that data. So we want to adjust it to let's say 20, since our biggest data was 17. And then maybe instead of 100, I'll go to 110. And now I can see everything.
Wait, what did you plug into the window?
So I said, let's start at 60s, let's go to 110. That way I'll go by tens. 60s, 70s, 80s, 90s, 100s, 110. Since I have a couple hundredths, I need to go to 110 so I can see that I had 2 100ths. And then I have all of my 90s, my 80s, my 70s, my 60s. And my Y's I changed from -2 to 20. Okay? Let's see the histogram on everybody's graph. I don't even care if you have everything in. I just want to see some histogram. Okay, that's set. Now zoom standard. Zoom stat. Beautiful. Okay, now just adjust your thing so you see everything. So change your window to 110 instead of, the X max to 110. That way you can see the hundredths. Okay, change your Y max to be a higher number. That's fine, you had different numbers. Beautiful. Change your Y max so you can see the top of this one. Yep. Yep. X min and max for your data, your X scale for how large your bins are, the Y's for your values. Excellent. Okay. And if you press trace, you'll be able to see. Now you can adjust your Y max so you can see all that stuff.
So what would I put?
So put just a bigger number.
Okay.
There you go.
Okay.
Good. All right. Good. Just different data here.
Yeah.
60 to 100. And it should be showing it.
Yeah. I think I forgot like one number.
Yeah, right. So your graph should be same as, let's see your window again. Oh, it's because you're going up to 120. If we just go to 12, there we go. And if we go just to 20, then we can see it everything. Okay, shrink your Y max. That way you see like taller graphs. Instead of 120, like 12 or just 20. Try that. Perfect. Now just change that so you can see that. So pick just a slightly bigger Y value. Okay. Our data is skewed left. Okay, stop there. Just draw. Just start. Just get a stat plot. Get a graph. Your stat plot's on. Graph. Go to graph. Doesn't see anything, right? Zoom stat. Nope. Zoom. Go down to zoom stat. Enter. Ta-da! Adjust your window to 60 to 110. Adjust your X scale. And you'll be able to make bin sizes of whatever you want. And you can go from there, okay? So, on your homework, you will be asked to make your own stem plots, make your own histograms. I would suggest that you would use a calculator to create your histograms. Even though there might not be that much data, use your calculator. That way you can practice using it, because on our quizzes, if you want to do things quickly, it's easier if you know your calculator's abilities, and you can use your calculator to create these histograms. Play around with different window sizes. You know, instead of 60 to 100 by 10s, I could have gone 60 to 100 by 5s, and then we'd have 60 to 65. Trace. 65 to 70, 75, 70, 75, and so on and so forth. So like there are different ways to be able to look at your data, okay? So play around with things, use your calculator on your homework, and now that it's CAV time, start your homework and let's do it.